Today we're going to complete Lesson 5-4, Solve Inequalities Using Addition or Subtraction. I want you to make sure that you are in your book on page 273 so that you're ready to begin. In your lesson today, we're going to learn how to use addition and subtraction to solve an inequality. The solving process is very similar to how you solve equations, so we're still going to be thinking in terms of inverse operations. What that means is that if I see an inequality that contains addition, I have to use subtraction to undo that operation. Likewise, if I see an inequality that shows me subtraction, I'm going to be using addition to undo that. Okay, in all of these cases, we're also going to be looking at inequality signs. Your inequality signs look like this. You have a less than and a less than or equal to. And then you also have a greater than sign and greater than or equal to. Notice that in the less than or equal to and greater than or equal to signs, that line underneath the inequality symbol is going to tell us that the number is included as part of our solution. So those dots on the graph are going to be colored in to indicate that that number does fit the description. However, when you only see a less than sign or a greater than sign, then you're going to see an open circle on the number line to indicate that that number is where our solution set begins, but is not a part of that answer. So the open circle says begin here, but don't include the number. Now let's take a look at the explain it question. Selena and Martin are waiting at the bus stop. The number lines show the possible wait times in minutes, T, for Selena and Martin. So Selena's possible wait times, you see a closed circle on the 15, and then you notice that the number line is shaded going to the left. So Selena's possible wait times begin at 15 minutes and decrease from there. Now look at Martin's number line. Martin's possible wait times also begin at 15, but there's an open circle there, and then the numbers continue shading to the right. So Martin's possible wait times also begin at 15 minutes, but does not include 15, and then increases from there. So take a look at question A. Who anticipates a longer wait? Justify your response with a mathematical explanation. So looking at your number lines, who do you think is going to wait longer? If you said Martin, you're correct. Martin's wait time is likely more than 15 minutes. But take a look at Selena. Selena is also going to possibly wait 15 minutes or less. Part B. If Selena and Martin both wait 10 minutes for the bus, whose possible wait time was closer to his or her actual wait time? Explain. So let's think about what would happen if 10 minutes was the actual wait time. So I'm going to use a red dot to signify that. In the case of Selena, she expected to wait 15 minutes or less according to her graph. If she only has to wait 10 minutes, then Selena is off by 5 minutes or less, because maybe she didn't have to wait 15, maybe she only had to wait 13 minutes or 11 minutes, or maybe even less than that. Now let's take a look at Martin. Martin also had to wait 10 minutes, but in Martin's case, he was expecting to wait more than 15 minutes. So his possible wait time compared to his actual wait time is actually 6 minutes or more. So who's closer? You guessed it, Selena. Now let's take a look at example 1. On the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. How much can Raul's second bag weigh without going over the limit? So you notice over here in the picture that Raul already has one bag that weighs 38 pounds and the limit is 50. So the question is, how much can his second bag weigh in order to stay within the limit? So we set up an inequality to represent the situation. The weight of the first bag plus the weight of the second bag has to be less or equal to the baggage weight limit, which is 50. So 38 plus the weight of the second bag, they're calling that P, has to be smaller than or equal to 50. So then we are going to solve this just like we did an equation, even though it's an inequality. We're going to use those inverse relationships between addition and subtraction to isolate the variable. In other words, get the variable by itself. So on both sides of this inequality, we're going to take away the 38 to see how much the bag could weigh. And in this case, the second bag could weigh up to 12 pounds. So 12 is what we call our reference number. Okay, that's the most that the bag can weigh. At most, 12 pounds. But it might also weigh less than that. Remember, the goal here is to stay under or at the 50-pound weight limit. If he goes over that, he might be charged extra for his heavier bag. Okay, so Raul's second bag must weigh 12 pounds or less to avoid going over the weight limit. So on the graph, you'll notice that 12 pounds is a solution, so we have a solid dot, and then we shade it going to the left to indicate it could be a number smaller than 12. One other important thing to note is the language that you read here in this question. The words "at least" will tell us that the number has to be at least a certain amount, meaning it could be bigger. So we would use a greater than or equal to symbol to indicate when we see the words "at least," meaning it could be bigger, but it might be equal to that number. The words "at most" indicate a less than or equal to situation. In other words, the number that's mentioned has to be that or lower. That's the highest it could go. At most, it can be a certain amount. In this case, the baggage weight limit is at most 50 pounds. In other words, we can't go over that, but we could be less than that. So we use a less than or equal to symbol. Now I want you to complete the try it. Come back and check your answer after you have filled in the first row of boxes to see if you set up the inequality correctly. Then we'll work on solving it. (64). So now we're going to learn how to put this on the graph. Since the symbol that we're using says greater than or equal to, then on the graph we're going to be putting a solid dot at our solution number, which is 64. So the solid circle on the 64 indicates that 64 hours could be one of the answers. But then we notice that this is a greater than symbol, meaning it tells us it could be more than 64. So we're going to shade that line going to the right to indicate numbers that are bigger than 64 also as part of our solution. Let's move on to example 2. Solve inequalities that involve subtraction. The weather forecast predicted that the evening temperature could get as low as -12 5/10 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7 5/10 degrees Fahrenheit, which was consistent with the forecast. What could the afternoon temperature T have been? So when we see the words, it could get as low as -12 5/10 degrees, that means that's the lowest it's going to go. It could be a number greater than that. So when we set up the inequality, T represents the temperature, and subtracting the 7 5/10 tells us by how much it dropped, and that number is going to be greater than or equal to the -12 5/10. Then we take a look at how we're going to solve this inequality. Since there's subtraction in the inequality, we're going to use addition to solve it, just like we did in the equations. So T must be greater than or equal to a -5 degrees. Greater than or equal to -5 means solid, closed in, filled in circle, because -5 is included. That's the or equal to part of your inequality sign. And greater than tells me that we're going to be coloring going to the right. Now take a look at the try it. The speed limit on a road drops down to 15 miles per hour around a curve. Mr. Gerard slows down by 10 miles per hour as he drives around the curve, and he never drives above the speed limit. At what speed was Mr. Gerard driving before the curve? So the speed he was driving before the curve becomes our variable. So I'm going to call that C. It says he slows down by 10 miles an hour. So whatever speed he was going, we're going to take away 10 miles an hour from that. And it said he drops down to going no more than the speed limit. So his speed here has to be less than or equal to the speed limit. Problem tells us that he is not a speeder. Okay, he never drives above the speed limit. And if the speed limit is 15, then that means he's either at 15 miles an hour, that's the equal to part, or he's less than that. Now we're going to solve this using our inverse operations. So we've already seen that whatever his speed was subtracted by 10 knows that that is not going to exceed our speed limit. So we are going to add those 10 miles an hour back to the original speed limit for the curve to see that his speed, C, must be smaller than or equal to 25 miles per hour. In other words, if he was going 25 miles an hour and he gets to the curve and he slows down by 10, he will be at 15 miles an hour, which is the speed limit on that curve. If he's going less than 25 miles an hour and he slows down by 10, then he'll definitely be under the speed limit, which is the 15 miles an hour. The next thing that we have to do is graph the solution. So to graph the solution, we're going to sketch a number line. Now, you don't need to make a number line that has quite as many lines or numbers like you see in examples 1 or 2. Instead, here's the strategy. Look at your solution. Find the number in your solution. In this case, 25. Okay? The 25 we're going to put on the number line somewhere towards the middle. Now I want you to make 2 additional marks, one in front of 25 and one behind 25, and label those with the appropriate number. You can either count by 1s or 2s or 5s. In this case, I've chosen to count by 5s on the number line. So the mark in front of the 25 would be 20, and the mark after the 25 would be 30. You can count by whatever sounds good to you, and it may just depend on the problem. Now, in order to graph this appropriately, we need to start with the circle. The circle is going to go on the solution number, in this case 25. Then I have to decide, is that circle going to be an open circle or is it going to be a closed circle? So when I take a look at where the 25 is and what inequality sign is in my answer, I see it says less than or equal to, which tells me that circle is going to be closed because 25 is a possible answer. Then we're going to shade in the less than direction, meaning we want all the numbers that are smaller than 25. So we're going to be shading to the left. Now I want you to take a look at example 3. Same type of problem here, but with fractions. And I know that not everybody likes fractions, so I'm going to take you through this one in just a second and show you how to combine the fractions using those common denominators. Then we'll complete the try it. Okay, go ahead and take a look quickly at your example 3. I've done the work over here on the side, and I've shown you that the common denominator is a 6. So 1/2 would be 3/6, and negative 2/3 would be a negative 4/6. Then you're going to add the 3/6 to both sides, okay, common denominator there. So these disappear, and then you have a negative 4/6 plus 3/6, so you're adding your numerators, so negative 4 plus 3 is a negative 1/6. So that's your final answer. And then you're going to graph it on the number line. So there's an open circle because it's a less than situation. So leave that circle here wide open. And less than means shade going to the left. Now I want you to take a look at the try it. See if you can figure out what the common denominator is, and then rewrite those fractions or mixed numbers using that common denominator. When you're done, check your answer. All right, let's go ahead and talk about that common denominator. You'll notice here in the inequality that I wrote that I changed the denominator to eighths because eighths is a common denominator for fourths and eighths. So the inequality becomes n take away 1 6/8. That's going to replace the 1 3/4, okay, equals a negative 5/8. That fraction does not have to change. To solve the inequality, just like we did equations, you're going to add both sides with the 1 6/8, okay? In order to do that, I've done over here in the blue section, okay, so this right here shows you the math that we're completing, the negative 5/8 plus 1 6/8. So I changed the the 1 6/8, I changed that to an improper fraction. And then I can do negative 5 plus the 14, so this piece right here in my numerators, to get 9/8, which is the same as 1 1/8. Now we're going to go ahead and graph this solution. So graphing this solution means put the 1 1/8 on the graph. And then decide, according to your inequality symbol, is this going to be an open circle or a closed circle? And in this case, my circle is going to be closed because you see that you have an or equal to situation. So we're going to put a solid dot on the number line. Then I also need to make some marks to show what the other numbers could be around it. So in front of 1 1/8, I have 1 whole. And after 1 1/8, I have 1 2/8. So all I've done is I've counted by eighths on my number line. Since the inequality sign is a less than symbol, less than or equal to here, we're going to be shading going to the left to show less than. All right, now I think you're ready to try a few more problems. See the next video that does the practice work for lesson 5-4.